Every component we have built writes into a file that ends in .html. Card, teaser, callout, all of them. And in every one of them, we have used a little piece of syntax, a dollar sign, and a pair of curly braces with something inside. That file is not plain HTML, it is HTL, AEM's template language. Some people call it Sightly. Today, finally, we learn the language we have been writing all along. This is part 1. Look back, episode 4 $sign, properties.title, that read a value out of a dialog. Episode 5, an expression with @context equals HTML on the end that rendered rich text without breaking the page. Episode 8, an expression that called a template to load a client lib. 3 episodes, 3 uses. Every one is built from the same few parts. An expression in curly braces, an object it reads from. Sometimes an operator inside, other times an option after an @sign. You have used all of it already without knowing the names. Today we learn each part, one at a time. Here is the shape, a $sign, then curly braces with an expression inside. HTL works out what the expression means and writes the result onto the page in place of the whole thing. What can go inside? A plain value, text in quotes, a number, true or false, or a list in square brackets, or the name of an object HTL gives you and you reach into it, usually with a dot, properties.name. You can also use square brackets with a key in quotes or with a variable or with a number to pick an item from a list, different ways to say the same thing. And here is the key point. The expression runs on the server while the page is being built. By the time the page reaches the browser, the $sign and the braces are gone. What is left is plain HTML. The browser never sees HTML at all. I created this profile component earlier, so I am not going to build it from scratch. We already covered how to create a component and its dialog in earlier video. Today we are focusing on the HTL. Let me quickly show you what is inside the component. This component has two text fields. One is for name, another one is for role. That's all we needed. Now let's look at profile.html. It has 4 important lines. The first one is $properties.name. This displays the name entered in the dialog. The second line is $properties square bracket role. The square bracket format does the same thing as the dot format. So there are two ways to access the same property. Line 3 contains same literal values, a string, a number, true, a boolean value, and a list inside square brackets. Notice the list. The items are displayed with commas and no spaces. These values are printed directly. Line 4 gets an item from the list using its index. The index is 1, which gives us the second item, beta. Remember, the index starts from 0. Now let's see how the component behaves when we add it in a page. This is the page I have created using content page template. Now I am going to add my profile component inside it. Let me author the component. Name John and role as AEM developer and save it. This is how it will look like. First, the name that was entered in the dialog. Second, the role that was entered in the dialog. To display name, we have used $properties.name. To display role, we have used $properties square bracket role. This is the third one, where we are displaying literals. And the last one was displayed using the index from a list. Properties is not the only thing HTL gives you. Every component gets a set of ready-made objects that you can use directly. Let's start with the component. Properties holds the component's own values, the values coming from its dialog. Resource represents the current Sling resource. So resource.path gives you the path of the component. Current node gives you the same component node, but as the raw JCR node. So these are different ways of looking at the same component node. In fact, properties is essentially the same data as resource.valueMap. Now let's move to the page. Page properties give you the properties of the page where the component is placed. This is a different node from the component. So remember this simple rule. Properties is the component. Page properties is the page. This is one of the most common things to mix up when working with HTL. Then we have inherited page properties. It works like page properties, but if the current page doesn't have the property, it looks up the page hierarchy and finds the value on a parent page. For example, you can set a brand color on a parent page and let all the pages below inherited. Next is current page. This gives you the page object itself, so you can access things like its title, name, and path. And finally, wcon made. This tells you which WCM mode you are currently in. For example, wcon made.edit is true while you are editing the page and false when you are not in edit mode. On its own, that is just a boolean value. But later we can use it to show or hide elements depending on whether the author is editing the page or viewing the published version. That requires a block statement, so we'll cover that in part 2. There are also a few other objects available such as component, current session, request, and log. You don't need to memorize all of them right now. The important ones to remember are properties, the component, page properties, the page, the source and current node, the component node from different APIs, and current page, the page object.
For this demo, I have replaced previous demo code with new one. So let's go through it line by line. The first line uses resource.name and resource.path. This gives us the information about the profile component itself, its node name, and where that node is located on the page. Currently, the node name comes from your JCR content repository. This is the component, and the node name going to be profile, and the resource.path going to be this one. The second line uses current node dot primary node type dot name. This tells us the JCR node type of the component. In this case, it will show NT unstructured. If I go to properties section, the JCR primary type is NT unstructured. Next, we have component dot title. This gives us the title of the component from the component definition. In our case, this will show profile because our component JCR title value is profile. Now let's look at page information. Current page dot title and current page dot path. This will give us the title and full path of the page where the profile component is placed. So our profile component is placed inside HTL demo page. So the current page dot path going to be this one, and title going to be JCR title, which is HTL demo. Next, we have inherited page properties dot brand color. This looks for the brand color property on the current page. If it is not found, it looks up the page hierarchy until it finds one. Let me show you. Currently, our page JCR content does not have brand color. So I am going to add brand color here as red. And then in the parent page, I am going to add brand color as yellow. Save it. Now let's go to our page and let me refresh it. As you can see, the current node name is profile and its path, and JCR node type NT unstructured, our component title profile. My current page title is HTL demo and my current page path is this, and page properties dot JCR title gives me the current page title, both are same, and the brand color as red. Now I am going to remove brand color property from HTL demo page and save it. Now when I refresh, it will show me yellow color, which is from EN page. Here, when we say inherited page properties dot brand color, this looks for the brand color property on the current page. If it is not available, it looks up the page hierarchy until it finds one. This is useful for site-wide settings. For example, we can define a brand color on parent page and let child page inherit it. If a child page has its own value, that closer value is used instead. Finally, we have WCM mode.edit. This tells us whether the page is currently in edit mode or not. So this is our page in edit mode. As you can see, it is true. When I open the page in WCM mode disabled, it will show as false. Even when I click preview and refresh the page, it will show it as false because currently we are not in edit mode, we are in preview mode. In this page, we are in WCM mode, disable mode. So with these few HTL expressions, we can access information about the component, current page, inherited page properties, and current WCM mode.
Inside the braces, you can also combine values and compare them. These are the operators you will use most often in HTL. Let's start with logic. Double pipe means OR. It is commonly used to provide a default value. Double ampersand means AND. Both conditions must be true. The exclamation mark means NOT. It reverses the value. Parentheses are used for grouping. They control which part of the expression is evaluated first. The order is parentheses, NOT, AND, OR, and then the ternary. The ternary is a simple either or. You give it a condition, then a question mark, the value to use if it is true, a colon, and the value to use if it is false. For example, properties dot featured question mark quote standard quote featured colon quote standard quote. Now let's look at comparisons. Double equals and not equals are used to check whether two values are equal or different. Then we have the ordering operators less than or equal, greater than, and greater than or equal. These comparisons are strict. HTL does not automatically convert one type into another. This is important when working with values from dialog. For example, a number field can sometimes give you a value as text. If you compare a string with a number, the types don't match and HTL can throw an error instead of giving you the result you expected. We'll see this problem in the demos, and later we'll use a sling model to handle properly typed values. One more small rule: spaces matter in HTL expressions. Use spaces around the question mark and colon in a ternary and around the @ sign when using options. And remember the basic precedence: parentheses, then not, then and, then or, then the ternary. These operators let you do quite a lot of logic directly inside your HTL expressions.
For demo 3, I have made few changes to the same profile component. I have added 4 new fields to the dialog. 2 checkbox, featured, active, and then department select with 2 options, engineering and sales, and finally rating number field. You will also notice 3 extra fields next to them. The author will never see these fields. Ignore them for now. They are actually the important part of this demo, and I will explain exactly what they do at the end. Now let's author the component. The component has already name and role. I have selected feature profile, currently active, and from the department I have selected engineering, and I have selected rating as 4 and click done. Now let's go through HTL operators one by one. First R. The expression is properties.role or team member. In the dialog, I have already authored role as AEM developer. Let me clear that and save it. As you can see, now it is displaying as team member. That means first it will check whether the property role has there or not. If it is not there, then it will pick the second option. Next, and here we have properties.featured and properties.active. Both the checkboxes are currently selected. So the result is true. Now I will untick active and save it. Go to dialog, uncheck active, save. Now you will see it as false because the first condition properties.featured will return true and properties.active will return false. True and false will be false. That is the reason you are seeing here false. Now not. The expression is not properties.featured. Featured is selected. That means properties.featured is true. So the exclamation mark simply flips the value. If featured is true, not makes it false. If featured is false, not makes it true. Next, grouping of operators using parentheses. Here in this example, properties.active, this is false, and whatever value you get here, irrespective of that, it will always print false. Now let me check active field and save it. Now you are seeing grouped as true. That means properties.active is true. Then it will go inside these parentheses. Properties.featured, this is true. Or properties.department. Currently the department value is engineering. So this entire expression will return true. True and true is going to be true value. Now I will change the department to sales. Save. Now you are seeing grouped as still true. Why? Because properties.active true, properties.featured true. Because of that, this entire expression will become true. True and true is true. Now I will uncheck featured also and done. Now you are seeing false. Properties.active true, properties.featured false, properties.department double equal to engineering. Currently the value is sales, not engineering. So this entire expression will return as false, and true and false is always false. Next, the ternary operator. The expression is properties.featured question mark featured standard. In this expression, first it will check properties.featured value. Currently it was marked as false. So if it is false, it will pick second value, which is standard. Let's check it. Ternary equal to standard. Now let me select featured value and click done. This time it got changed to featured. Properties.featured is true. When it is true, it will pick first value. The last ordering. The rating is 4. So rating greater than or equal to 4 is true and rating less than 3 is false. True and false. Now I will update the rating from 4 to 2 and click done. Now the rating is 2. 2 greater than or equal to 4, which is false. 2 less than 3, which is true. Now let's get to those hidden fields, because without them some of the logic we just tested would not work correctly. Feature type hint. If you notice the properties, it has name and its value is featured at the rate type hint, and it has one more property value, and the value of this property is boolean. That means whenever I selected this checkbox, it will store the value in the form of boolean, or else it will store it as string. So if I notice here, featured, the type is boolean. If this field does not available, it will store this value as string. Let's delete this property and delete this field from dialog and reauthor it. Now when I refresh my properties node, you will see featured and type is string. Earlier we have type as boolean, string and its value is true. Similarly for active type hint, we have marked it as boolean. That's why you are seeing the type as boolean. Now rating. Rating is a number field. So we have marked the value as long. That is the reason you are seeing the rating type as long. Why this is needed? Because in our component HTL, when I say properties.rating, this should be long or integer. If it is a string, this expression will fail. It will throw an error. That is the reason we have marked rating as long.
Now let's get to the most important idea in HTL, escaping by default. This is one of the main reasons HTL is safer than older templating approaches. Every expression in $curly braces is automatically escaped based on where it is used. For example, if an author types something like a bold tag, then hi, then a script tag calling steal, HTL does not execute it. It does not treat it as HTML either. Instead, it displays the value as text. So the script does not run and the HTML tags are not rendered as markup. The important part is that HTL also understands where the value is being used. Inside an HTML element, it applies HTML escaping. Inside an attribute, it applies attribute escaping. Inside a link, it handles the value as a URI, and when a value is placed inside a JavaScript string, it applies the appropriate JavaScript escaping. So you don't have to manually escape every value yourself. This is different from older approaches like JSP, where developers had to remember to escape output themselves. With HTL, the default is safe. And when you do need to allow something more specific, you explicitly choose a context. The important rule to remember is HTL escapes by default. Contexts are used when you intentionally need a different type of output.
For demo 4, I have added one more field to the profile dialog, a rich text field called bio. It will save values in /bio. I will author some content in it with bold text and link. Now let's look at what happens when we read that value in HTL. I have 3 lines here. All 3 are reading same properties.bio. The only difference is the context. First, there is no context specified $properties.bio. The result looks wrong. You can see HTML tags printed as text instead of being rendered. That is because when an expression is inside an HTML element, HTL uses text context by default. So the HTML is treated as text, not as markup. Now look at the second line. Here I have used @context as text. The result is exactly same. That makes sense because text is already the default context in this situation. So explicitly specifying text does not change the output. Now the third line. @context HTML. Now the bold text is actually bold and the link is rendered as a link. So context equal to HTML tells HTL that the value is intended to contain HTML markup. But there is an important point here. HTML context does not mean that every piece of HTML is allowed to pass through. HTL applies the appropriate security handling to the output. Let me demonstrate that. I will open the rich text source and add a script tag. The safe formatting is still there, but the script does not execute. HTL filters the output so that dangerous markup is not simply rendered as executable content. And look at the plain text version. The script is displayed as text there, so it is harmless as well. This is the one of the important security benefit the HTL's context aware escaping. Now let's look at last example. Number. Here we have properties.rating @context number. Our rating is a number, so HTL outputs the rating. Now I will use the same context with the name property. The name is text, not a number. So the number context cannot use it as a valid number and the result is 0. The number context is useful when you expect the value to be numeric. The main takeaway from the demo is that HTL context control how an expression is safely output. Text treats the value as text. HTML allows safe HTML markup to be rendered, and number expects a numeric value. The context you choose should match what the value is supposed to contain.
Here is the complete set of HTL contexts, grouped by where the value is used. Let's start with values inside an HTML element. There are three contexts here. Text is the default. It treats the value as plain text and escapes HTML characters. HTML allows safe HTML markup to be rendered, and number is used when you expect a whole number. It validates the value and outputs 0 if it isn't a valid number. We have already seen all three in the demos. Now, values inside HTML attributes. Attribute is the default for a normal attribute value. It escapes characters that could break out of the attribute. URI is the default for attributes like href and source. It validates the URL and produces no output if the URI is unsafe. Then we have values inside JavaScript and CS. For JavaScript, we have script token and script string. Script token is for a JavaScript token, while script string is for a value inside a JavaScript string. For CSS, we have style token and style string. Style token is for a CSS value, while style string is for a value inside a CSS string. There are also two other contexts, attribute name and element name. We won't cover those here because they are used with data-sly attribute and data-sly element, which we'll cover in part 2. One important thing to remember, context is itself an HTL option. You normally don't need to specify it because HTL already knows the context from where the expression is used. You specify a context when you need to override the default. So the pattern is simple. HTL chooses the protection based on where the value lands. You specify a context when you intentionally need something different. There are two more places where a value can be used and they need their own context. First, inside a script. If we put an author's value inside a JavaScript string, we need to make sure that value cannot break out of the string. That's what script string is for. It escapes the characters that could break the string, so the value stays as a string. Its partner script token is used when the value is a JavaScript token such as a variable name or number. Now inside a style block, style token validates that the value is a valid CSS value such as a color, size or keyword. If the value isn't valid, HTL outputs nothing. Style string is used when the value is inside a CS string. And finally, there is unsafe. This turns off the normal escaping and protection. It should be treated as a red flag. If you see unsafe in HTL, Stop and understand why it is being used before allowing it. The main idea is simple. Use the context that matches where your value is going.
For this demo, I have added one more field to the profile dialog, brand color. This is a text field and the property that will be stored in JSR content is brand color. I have also added two expressions to the HTL, one using style token, another one using script string. Let's start with the style. Now, in the component dialog, I will leave this accent color empty and save it. You will see the name in the red color. This is coming from base style. Now I will enter a color in the dialog. Click done. Now the name turns blue. That means the value from the dialog is reaching this style block through context style token. Now let's look at the JavaScript. The script takes the profile name and puts into JavaScript using context script string. Currently in the dialog, the name is set to John. Now refresh the page again, open the browser console and you will see profile name from HTL as John. So the name was passed to JavaScript successfully. That's the basic idea behind these two contexts. Style token is used when a value is expected to be a CSS value. Script string is used when a value is placed inside a JavaScript string. Both contexts tell HTL how the value should be safely written to the page.
Last piece, the other options. An option goes after an @ sign and changes how the value comes out. You have already used one all through the contexts. Context is an option. Here are the two others you will use all the time. Join takes an array, a list, like tags, and turns it into one string with a separator you pick. Remember that list back in the first demo printed with commas and no spaces? That is the default. Join is how you fix it. Format takes a date and prints it however you want. Year, month, day, hours, minutes. Change the pattern and the output changes, the stored date stays the same. So that is the whole family, join, format and context, all after the @ sign. Two of them shape the value, one keeps it safe.
For this demo, I have added two new fields to the profile dialog. First, a tags multi-field. This is a multi-field. Inside this multi-field, I have used a text field. Second, published date picker. It will save values for the published property. The published field also has a type hint set to date, so HTL can format the stored date. Now let's look at the HTL we have added. For the tags, the first line simply prints the raw values, properties.tags. The second line uses the join option, and for the published date we use the format option. Now let's open the dialog and author these fields. Inside tags, I am going to add HTL Cycly AEM. Now I am going to set some published date and done. Now let's look at the output. First you will see raw list. Here we are simply using properties.tags without any option. The output is HTL Cycly AEM with comma separated. This is the same behavior we saw in demo 1. When HTL prints any array directly, it uses a comma to separate the values, but it does not add spaces. Now let's look at the second expression. Here we have used join. Now the output will be htl.cycly.aem. The join option lets us choose the separator between the values. I will change the separator to slash and save it. As you can see, dot will be replaced by slash. Now let's look at the date. Here we have a date format and properties.published. Notice the order. The pattern is the main expression and the date is passed to format option. This is how the output look like. Year, month, date and time. Now I will change the format. I will remove this hour and minute from here. Save it and refresh the page. Now you will see year, month and date. The stored date has not changed, only the way we display it has changed. And that's it. We have now covered two more useful HTL options. Join for displaying list with custom separator and format for displaying dates in the format we want. Both uses syntax to control how the value is handled.
Let's put it all in one picture in the order we learned it. An expression reads from an object, properties, resource, and current node for the component. Page properties, inherited page properties, and current page for the page, and WCM mode for author versus publish. It combines and compares with operators or and not, grouping the ternary and the strict comparisons. It stays safe to context, text, HTML, and number inside an element, attribute and URI in an attribute, and the script and style context inside those tags with the right default already chosen for every spot, and it shapes the value with options after the @, join for lists, format for dates. That is the whole first half of HTL. Every $sign you have seen in this series explained, and all of it runs on the server before anything reaches the browser. What we have not touched is the other half, the parts that decide whether an element shows at all, that loop over a list, that pull one component into another. Those are the data-sly attributes. That is part 2. That is part 1. The expression, the objects it reads, the operators that combine it, the contexts that keep it safe, and the options that shape it. The language behind every component we have built. If this helped, subscribe. The series builds on itself, and part 2 is next. The written version with all the code is on the Substack. And drop a comment. I read every one. Next episode, the block statements. The data-sly attributes, data-sly use to bring in logic, data-sly test to show or hide an element, data-sly list and data-sly repeat to loop, data-sly resource and data-sly include to pull one thing into another, data-sly template and data-sly call to write a piece once and reuse it, data-sly text attribute and element to change the markup itself, and the true contexts I still owe you, attribute name and element name come with them, and data-sly unwrap to tidy up after all of it. Expressions fill the markup, these attributes build it. That is part 2. This is AEM Insider. Start took on AEM.